Okay, here's a couple of nice questions. And these deal with the circular nature of trigonometry, or looking at an arc that is rotating around middle. So it says a Ferris wheel. Let's draw a Ferris wheel. Ferris wheel has a diameter of 25. So 25 is the whole way. To go halfway then, that's 12.5. And that'll be a radius. And it says, what will the distance traveled be to go around once? So if they start here and they go all the way around, they want to know how far that is. Well, here I've got some formulas that can help us figure that out. The one with the W formula, those are for angular velocity, and those are like things like how long it takes you to go around once. So revolutions per second, revolutions per minute, RPM, those are angular velocity. Here we're not looking at velocity at all. Here's another formula, and this says the velocity of something is equal to this, and that's an arc length. That's what S stands for, divided by time. And again, on this question, we're not worried about time. We're just wanting to know how far you go. So let's look at this formula here. So this formula, theta, stands for a revolution, or an arc, not an arc length, but it's an angle, I guess. So what kind of an angle rotation happened? S stands for an arc length, and that's the distance around a particular thing. And I could go to here, or I could go to here, or I could go all the way around. And R stands for the radius. So I think I'm going to use that formula right there. So an angle is equal to the arc length divided by the radius. In this case, they're wanting to know how long to go all the way around. Their one is to solve for S. So the formula, if I multiply both sides by R, will be S is equal to R times the angle. Now the angle in all of these, in this one, not that one, this one, and the angular velocity too, all of those measurements for angles have to be done in radians. So usually we're good with degrees. So if I were to go all the way around a circle, that's 360 degrees, right? But these formulas, I have to put that into radians. So to go all the way around a circle in radians is actually 2 pi, because 360 degrees is the same thing as 2 pi. So that's what I'll put in for the angle. So S is equal to, my radius is 12.5, multiplied by my angle of revolution, and that is 2 pi. So times 2 pi. Okay, so S is equal to, that would be 2 times 12.5 is 25 times pi. What do they say to one decimal place? So just do that on your calculator. 25 times pi, it'll be 75, 78, somewhere up there. Okay, next question. A bicycle attire, radius. If I travel 3 kilometers, how many times will my wheel go around? Same kind of question. I'll use the same formula. So it'll be theta is equal to S over R. And this time we know what the arc length is. That's the 3 kilometers. And we know what the radius is, 27. Oh, I'm going to have to do some work there because I have kilometers and I have centimeters. I'm going to have to convert that. Anyway, I have those, and I'm looking for some kind of an angle measurement. And I don't know what that, like they say, how many times will it go around? That's what this is looking at. So one revolution, not two, one revolution will be the same thing as 2 pi radians, or 2 pi going around. So I'll be able to use this later to figure out actually how many revolutions it went. But let's first use this formula to figure out what that arc, or what that angle revolution is. So theta is equal to, the arc length is 3 kilometers, divided by the radius, 27 centimeters. trouble here is that the units don't match, so I have to convert one to the other. Let's convert the kilometers to centimeters. So kilometer, hectometer, decameter, meter, centimeter, no, there's another one in there. Decimeter, centimeter, millimeter. So from kilometer to centimeter, I have to go 1, 2, 3, 4, 5. So I have to multiply it by 1 with 5 zeros, or move the decimal 5 places to the right. So that'll be the same as 3, and then I've got to put in 5 zeros, and that now will be centimeters divided by 27 centimeters. So the centimeters will cancel, and this will give me my angle measurement in radians. Okay, so let me do that quick. Okay, I'm back. So that turns out to be 11,111 point, a bunch of ones, radians. So that tells me not how many times it went around, but how many radians there would be. So we can come back to this unit here of transferring from one unit to another unit. So I have 11,111.11 radians, and I'm going to multiply it by this conversion factor where 2 pi radians are the same as 1 revolution. So I'm just going to take this number here and divide it by 2 pi. Let's see if that works. Where's my pi button? There's pi. Okay, so that comes down to that wheel would have rotated 1,768.388 times, or revolutions. They say round to the nearest revolution, so I'd be calling it 1768 revolutions. Right, hopefully that helps you with those questions. It's a little funny having to think in radians instead of thinking in degrees. But all of those formulas and any of these questions that I'm dealing with here, if I'm using this formula, any angle that I give has to be in radians, not degrees.